Once we've had the faults entered into the trainer, if we need to clear those so that it's ready for a different student, or if we want to clear those and put new faults in for that particular student, there's basically 4 ways that we can accomplish that. The first is that we can use either C for clear or E for erase. So let's go ahead and I'm just going to use C, so I'll push C. And the next number is the PC slot number that the board's in. In this case, it's still 1. And we want to get rid of that fault that we put in that was number 12. So I'll just push 1, 2 for the 12, and then press the Enter key. And now that particular fault is no longer in the system. If I do display fault, Enter, you can see that the fault has been removed. The other way that we can clear faults from a particular card slot is to just use 0, 0 for the fault number, and for that particular position, in this case we would use the C and position 1, and then enter in the 0, 0. Any faults that would be programmed in for that particular PC slot would be eliminated. So we'll be back to the no faults for that particular position. If we want to clear the faults out of all the trainer, in other words, out of position 1, position 2, and position 3, we've got basically 2 ways to be able to do that. We can use the C, again, for clear, and then we can just use 0 for the PC connection, and then 0, 0 for the fault number. And that way it will clear all the faults out of the trainer completely. If we want to clear the faults and go back into the default settings, all we have to do is use the shift and the clear connection off of the board. So if I hold down the shift and push the clear, the unit then will go back in to its default mode, and any of the troubles that had been entered in will be have been removed. So if I do the display fault, enter, and you can see that there is none that is in the trainer. Besides the boards that come with the card sets for the technologies that you'd be studying, there's also cards available that will allow you to set up any experiment that you might want. This particular one is the experimental card set for the 130 trainer itself. It has the connections for all the pins, or most all the pins, and in the power and signal distribution is at the top and the bottom, so that you can set up simple circuits on that experimenter board that might correspond with things that you would want to do that's not available in the NIDA materials. Okay. Now that we've looked at the trainer and know about the basic operation of entering faults and stuff into the trainer itself, let's take a look now how we're going to apply the trainer in the manual mode from one of the PDF lessons. I think you're going to find that the PDF lessons are very helpful for student understanding the basic concepts. In my opinion, there's more material in the PDF version of the lesson than in the computer-aided instruction module. So I think you're going to find that this is going to be very helpful for the student. So let's do that now. Action. If you go to the Create site, we can get to our NIDA PDF files for our study by going to Services, dropping down to Training, and then to the Online Tutorial. So just click that, and we'll be on our online page. Currently, the only thing that's linked is the DC electronics, so we'll just go ahead and click on that. And in the DC modules, you will see a number of areas. The one today that we're going to be looking at is going to be the series circuit troubleshooting, so we can see the comparison between using the PDF version as well as the computer-aided instruction version of the software. Besides the NIDA material, you'll also find other study topics and sources available off of this site than just the NIDA. Troubleshooting is out of Block 3, Lesson 2. So we'll go ahead and just click on that so you can see what the PDF is going to look like. So the PDF lessons are all here. This is all of the study materials for that particular topic, and there's a number of pages that are available for this particular study unit. In fact, I think there's like 10 or 11 pages. But you can see it goes through the analysis of how to determine what the voltage drop is going to be in a simple series circuit so that you know exactly what's supposed to be there for doing the troubleshooting. It also goes through some scenarios with components being open, as you can see this, so that you'll have a good idea of how to apply what you actually measure and see in the circuit with the type of problem that you might have. But to get into the exercise for the experiment, you need to look under the lab exercises and study materials. And right here is the series circuit troubleshooting lab exercise. And it's stated so that you can hopefully easily find that. So let's open it up and we'll go through. And it will give you some analysis requirements. So starting off, that's what you're going to be doing, is determining what the circuit looks like. So you're going to be looking at that circuit board, drawing out the schematic diagram in the box provided. You're going to determine what the current and the voltage drops are going to be through using Ohm's law calculations. And then you're going to move over to the trainer, and you're going to activate the trainer and actually make all of the measurements. And it goes through and it tells you how to apply the power and so on, but I'm going to be demonstrating that for you as well. There's places to enter all of your measurements as you go through, and it also tells you what the fault insertion must be. So it'll tell you to type in the F1 110, for example, for an open R3 circuit as indicated here. And you're supposed to draw it so that you can actually see that. It's going to go also into the circuit B. That's the middle series circuit on that circuit board, just as it's going to be in the CAI instruction as well. But everything is on the PDF. This is just the way I set this up is just that the exercises are separate from the labs so that the student can study the exercises at home and then work with the labs. And again, as I was saying, it tells you exactly what you need to do here. Set the switches on the board. Also how to enter in the fault itself. So in this case, we're entering 3 faults, F104, F110, and F115. That's fault 4, fault 10, and fault 15 for that 6A card. The F110 is the only one that deals with the circuit A. So I think you'll see that it's pretty easy, which we'll demonstrate right now. Now we'll put the trainer into manual mode. Remember, to do that, hold down the shift key as you turn on the power switch, and you can let go as soon as you hear the little squeak. As you can see in the display, we're in manual mode, and we don't have any voltages coming from the negative supply or the positive supply yet. We've already pre-inserted the circuit board that we're working with, and we've got the switches in the positions that the PDF told us to put them in. So we're all set with that. We've got basically, I'll be working with the A series sequence. That's the series circuit that's on the left side of the board. It's comprised of a 2K, a 1K, and a 1K for the 3 resistors, for a total of 4K ohms, which gives us about 3 milliamps for, with 12 volts being supplied. So we should have the 6 volts across the 3 volts as we calculated from the PDF, and across the 2 1K resistors we should have 3 volts apiece. So to start the experiment off, we're going to turn the power supply to 12 volts, and that's what it said in the documentation. So there's 5 volts, there's 12 volts. And then we're going to need to apply that power supply then to the PC1 position. And again, we'll need to use the DC switch for that. So now we've got the voltages applied. Now, I'll go ahead and I'll make those measurements across each of those 3 resistors so we can see exactly what's there without having any trouble inserted into the machine, as it's told us in the procedure steps. So I will measure across R1, and it says between points test point 2 and test point 3, and they put test point 2 way over here instead of being over on the top. So I'll stick it right there, and you can see that we've got 6.12 volts. And this is what I'd be entering in on the chart on my PDF for resistor R1. I'm going to now move to resistor 2, and that's between test points 4 and 5. And I measure 3.089 volts, or just call it 3.09 volts. And then we'll move down to test point 6 and 7. This would be for R3, V sub R3. And we're measuring the 3.089 volts as well. So if we look at our calculations that we did, we're pretty close to what we calculated as 6, 3, and 3. And again, remember that for most of the work that we're going to be doing, we can vary between plus and minus 10% from those voltage values. The values that we're going to be ranging from will be for the 6 volt, 5.4 volts to 6.6. That would be the range that we'd be looking at as being good. And for the 3 volts would be 2.7 to 3.3 volts for R2 and R3. Okay, so let's go ahead now and we're going to insert a treble into this system. So I'm going to take the voltmeter off right now. And we'll enter in a fault. So we'll push the F, and we're in position PC1. So I'll push the 1 for indicating that it's that particular module that we're going to be working with. And the treble I'm going to insert is going to be an open. And the one that I'm inserting is 10. So I'll just push 1, 0 for that, and then press the enter key. And now that particular treble has been inserted, and again we can do the DF and enter, and it's going to tell us which fault we inserted, which the F110 is the one we wanted.